All right, we are going over 8.8 notes that continued, so we did not do all of 8.8. We did part of 8.8. This is the second part. So in this part of it, we again were talking about systems of linear inequalities. So remember what we worked on today for homework is we graphed one inequality and then we had to shade one side or the other side to decide where our solutions were, right? Okay. Today we're going to be graphing two. So remember, a system is two or more inequalities, correct? So remember when we did it before where we would graph, just to give you an example, earlier in the chapter we would have a line with maybe it looked like this. We would graph that line. And that was one of our lines. Then we would graph the other line, and let's say the other system, and just for the sake of just showing you a visual, let's say that the other line when we graphed it looked something like, and you would graph this one. And then I said to you, what would be the solution? And what did you know? How did you figure that out? What was the solution to this system? So I graphed this line, I graphed this line. The solution is what, Charlie?
You test a point.
That was today. Go back a little bit further. These are just equations. So what did Chad, how do I know?
-1, -1.
Okay, so it's where the two overlap each other, right? Okay, so you're just a little ahead of me, Charlie. We're going to take that concept and this concept and put it together. Okay, so now you agree with me that there's just one solution here that works, correct? Okay, remember when we work with inequalities, there's lots of solutions. Okay, so keep that in mind. Okay, so a solution of a system of linear inequalities is any ordered pair that makes each inequality in the system true. So remember today when we graphed something like this, we found a whole region that worked. Here we're going to graph this, we're going to find another region that worked. And guess what? Where they overlap is our solution. Okay, so let's do one so that you can see it. Okay, so look at this first one right here. I have y is greater than or equal to -x minus 2. It is in slope-intercept form. So my y-intercept is what? What's the y-intercept, Brittany?
0, -2.
Okay, 0, -2. What is my slope, Mark? Tell me my slope.
-1.
Okay, so my slope is -1. I'm going to put it in that rise over run form. And now and by the way, is this going to be a solid or a dashed line? Anybody?
Solid.
Solid. Remember the line. So this one's going to be solid. Okay? So let's graph that. Okay, what was my y-intercept again?
0, -2.
Okay, so there's my y-intercept. What is my slope?
-1.
Okay, so I'm going down one to the right one. And then remember to make a nice line, just keep going with your rise over run. So down one over one, down one over one. And then we said that that was a solid line, is that right?
Yeah.
Okay. So looks like that, correct? And by the way, actually, let me try. That. When you do these, because you want to make a good boundary line, I would actually make this really long so it covers your entire graph. Because now I can go, okay, either my answers are on this side or either my answers are on this side. So I can see that that has created my boundary, or it's dividing answers from not answers. I just need to figure out which side are my answers. So what am I going to do at this point? So this is what we did today. We're not doing anything different. Tell me what I'm doing, Jacob.
Test point.
Okay, what test point am I going to use, Jacob?
0, 0.
0, 0, because it's the easiest. When can I not use 0, 0 as my test point? When am I not going to use that, Chad?
When the line goes over the 0, 0.
Right. So remember, the point that I check always has to be on either one side or the other of the line. So I'm going to test 0, 0. When I test 0, 0, so remember thinking about what is my original equation, you guys, it was y is what?
Greater than or equal to negative x minus 2.
Wait, say it again.
Negative x minus 2.
Negative x minus 2.
Plus 2?
Minus 2.
Do I have it right?
Yep.
Okay, so all I'm doing here is, remember, this is my x value, this is my y value. I'm plugging them in. So y is 0, greater than or equal to. My x is 0. And I'm simply solving. So I get 0 is greater than or equal to, obviously, negative 0, no, negative 1 times 0, 0. And 0 minus 2 is negative 2. Is this a true statement? Is 0 greater than or equal to negative 2?
No.
Yeah.
Yes.
Yes, it is. Right? So this is true. If this is true, what does that mean? What's it mean if this is true? What's it mean, Charlie?
Shade in the side.
Shade in the side that that point is on. So this is getting shaded in. Okay, so those are my solutions. Okay, we didn't do anything different than what we just did today, right? Okay, now what we're going to do is we need to graph the other inequality on top of this one. Okay, so if I go back, let's do this one right here. And this is not in slope-intercept form, so I need to get it into slope-intercept form. What am I going to do that? Mark?
Plus 2.
Not yet. No. I'll divide. What am I going to get rid of first?
X.
The x. How do I get rid of the x? Say minus.
Minus
X. So I'm going to subtract it off of that side. So that cancels. I have negative 2y is less than. Can I put those together? Can I put 4 and negative x together? Can I or not?
No.
No. So I'm just going to write it as negative x plus 4. What's my next step then? What am I going to do now? Cameron?
Get rid of the negative 2.
How do I do that, Cameron?
Divide.
Absolutely. And by the way, I'm dividing by a negative number. Tell me what that means.
The sign.
Casey?
Flip the sign.
I'm going to flip the sign. So immediately I'm going to come down and do that or I'm going to forget. Okay? So I'm dividing by negative 2. My y is now by itself. I have flipped the sign. Remember, there's a 1 there. So this is actually negative 1 over negative 2. So how am I going to write that? Travis?
1x over negative, or minus 2.
Well, hang on. 1, isn't this divided by negative 2 and this divided by negative 2?
Yeah.
So
Then negative 1 over negative 2 is...
is positive 1 over, right? The negatives cancel each other out. Okay? And then 4 divided by negative 2 is what? Anybody?
Negative 2.
Okay? So now it's in slope-intercept form. Okay? So, what is my y-intercept?
Negative 1/2.
No.
0, negative
0,
2.
negative 2.
0, negative 2. What is my slope? 1/2. Good. Okay? Now I'm going to graph. So remember, we already have this graph. Now, here's what I would suggest. I would probably get a colored pencil. So if you don't have one, go back and get one. And I would shade in a different color. Or I would do this problem in a different color because visually it will help. So get a colored pencil.
Can you just like push harder down on your pencil? Like make the first shade light?
As long as you can distinguish, and eventually you're going to just use the same pencil and you'll see, but
Yeah.
initially when you're learning this, the visual of the two different colors is very helpful, because otherwise it can get confusing. Okay? All right, so when I am looking, I'm going to use that different color. I'm going to use red. I am going to graph. What is my y-intercept?
0, negative 2.
Okay, so it's same place. What is my slope?
1, 2.
Okay, so it's up 1, over 2, correct? Up 1 over 2 is to make a nice line. Up 1 over 2, and so on. Okay, so you can see the line, correct? Okay, dashed or solid?
Dash.
Dashed on that one, correct?
Yeah.
Okay,